event. Hi, everyone. I am Devraj Chakraborty, the domain head of the data centers at BIS Research. I will be your moderator for today's webinar. And on behalf of BIS Research, I would like to welcome you all to this event, centering on carbon neutral data center practices. Just to give you some little introduction of our organization, BIS Research is a leading global market intelligence research advisory company that focuses on emerging trends in technologies which are likely to disrupt the dynamics of the market. The mission is to harness the potential of disruptive technologies to make business thrive in today's digital age. That's all we do. I mean, we try to identify the niche markets, we hit the target, and we help our clients with the specific business problems that they have related to those technologies. I would also like to introduce our guest speaker, Mr. David Enright. Is such a jolly person, but when you listen to the experience, I mean, you will be awestruck. He's an experienced and dedicated business professional with 29 years working with Department of Defense, worked with multinational private and public sector organization. His primary focus is developing and executing strategic step-up growth initiatives in emerging markets and technologies. And I believe that today we are discussing one of the growth or emerging markets, especially with respect to immersion cooling and liquid cooling. He is specialized leadership in developing improved business operations to include financial and operational efficiencies, implementation of next generation HPC platforms, global blockchain development strategies, biotechnology, viral cell, gene therapies, and market intelligence assimilation for public applications. I hope I was able to introduce you properly, David.
That was a mouthful, and you can just call me JD. That's fine. We've had conversations before, so JD is fine.
Perfectly fine, JD, with me. So let's start with today's, a little bit introduction of what we are going to do here. So we are talking about data centers. One thing which is very important to understand about these big buildings is that they are huge. They consume a lot of water, energy, and they have become quintessential to human development and existence. I mean, we cannot imagine our day-to-day lives without these data centers. I mean, if you are on Instagram, if you are using WhatsApp, you are calling somebody, anything you are doing digitally using an internet, that requires a data center at the back end to process all that data. However, the downside of such a huge operation is that on an average, data centers consume 190 terawatt hours of power globally, which is approximately 4% of the total energy being consumed by the world. 4% is not that much, but if you compare, this is more than enough to run the state of New York for a year. And mind me, New York just consumed 149 terawatt hours last year. So it's even less, even greater than that. These data centers annually consume somewhere around 700 million liters of water. Just to explain you the stat, on an average, 1 million people in USA, they require 700 million of waters in a year. And if we compare it with the African numbers, 15 million people can live off with 700 million of liters of water yearly. The largest data center that is situated in China, run by China Telecom, is 10 million square feet, and it's equivalent to 130 football fields. So the agenda is clear. We are trying to, talk about the current issues with the data center, which I've already explained. They are huge. They consume water and they consume energy, but they are quintessential. They are very important for human existence. What exactly is carbon neutral data center? Pathway to carbon neutrality, and of course, we will hear from JD here, his perception and his thoughts related to this particular title, and of course, specifically towards immersion cooling and liquid cooling. What is the current adoption and future outlook, challenges and conclusion, and of course, at the end, we will have a Q&A session for you all, put up questions and all. So Nikita, let's move on to the next slide, please. We have already discussed the issues. You can see on an average, if we see that the energy that is required to run data centers globally is 190 or 191 terawatts odd. This looks quite normal because since 2018, the number has been same. However, if you look at the data properly, you would see that the co-location data centers and hyperscale data center intervention has increased. And with the launch of 5G and other applications that we use on a daily basis, ChatGPT is there. More number of data will be required to be processed on a daily basis. And if you look at future possibilities, uh, with 6G, we are talking about terawatts or terahertz frequency also. So this number is going to look a way ahead, or it's going to increase in next 5 to 10 years. On an average, as I said, 700 million waters in gallons is 164 million gallons for hyperscale and 6.57 million gallons for co-location. I mean, for current situation, it's very much important. I mean, you can't live without these data centers, and this much of requirement or this much of consumption is there. But what about the things that can actually help us mitigate this, or reduce some of it, so that you can reuse that, or utilize it for something different or something useful maybe. Next slide, please. So just to give you a small introduction to carbon neutral data centers, we believe carbon neutral data centers are data centers or buildings that are preferably carbon neutral in their operations. I mean, there are scope 1, scope 2, scope 3 emissions there. However, we stick to the definition of scope 1, where the carbon or the data center is actually emitting anything. To suffice it, a carbon neutral data center has to run on 100% renewable energy. The power usage effectiveness with current standards must be less than 1.2. 1.2 is something that is achievable. I would like to change that fact to 1.001, basically. Carbon usage effectiveness, no carbon emission. So this is what a carbon neutral data center looks like, or can be defined as. Currently, if you look at the overall adoption rate, merely 2 to 3% of the market, or the 2 to 3% of the industry or data centers can be termed as partially or complete carbon neutral. So I like to use the word partially because that is the truth right now. Nothing is 100% carbon neutral. That's a myth. So next slide, please, Nikita. So this is a clear pathway that we believe is going to happen with the data center industry. This is an overall picture. What is going to happen right now? If you look at current emphasis, it's more towards green data centers. Data centers are trying to come up with in-campus production units, especially renewable. I mean, they are installing solar power, they're installing wind power, they're trying wind power, they haven't done yet. So the idea is to get something, if not the entire thing. In the next 5 years, which is basically 2026 to 30, we will be seeing much more adoption, or at least the term green data center will become common. At least 50% of the overall data center market, especially in the developed nations or the markets that we call FLAP, France, London, and Frankfurt, and of course US, will have 50% of its data centers running on renewable energy, either through agreements from the local vendors or in campus production. We will see a major chunk of carbon neutral data centers coming from the Nordic regions, especially colder climates, because they have a natural advantage. They can pump the cold air outside into the system, and you can reuse that heat, or reuse that uh, used air for some other purposes, for heating or district heating or something like that. So that is something that we look into next 5 years. It's very fake, or it's very foggy to say that beyond 2031 or 35, there will be a lot of change. However, in 2030, there will be an important event that's going to change the entire carbon neutral or the data center industry all along. NTT has declared that they are going to launch 6G in 2030. That means your average power density per rack will move from 20 kilowatts, which is the highest right now. It's not the highest, but the average highest, to 100 or even 200. More number of data center will be consuming that much power density, because that is required. We're talking about terahertz frequency there. It's an important event. What's going to happen after 2030? We believe that the hyperscale operators are able to achieve 100% carbon negative status as promised by Google, Microsoft, Facebook, and AWS. They've all promised that by 2030, they are going to achieve this. The plan is not clear yet. They believe they have started offsetting that carbon that they are emitting through a carbon credit system. They have installed renewable energy. Apple and Google, they are using 100% renewable energy right now itself. The only matter of time is to see if they can achieve or reduce their scope 2 and scope 3 emissions, which is something that they are not emitting directly. Uh, by 2036, we will see that government policies across the globe will be supporting this idea. They have already started supporting this idea. If we talk about government policies, European Union is one of the leading ones. There is a policy called the European Green Deal or Europe Green Deal that is dictating that by 2030, almost all the data centers that are operating in Europe are going to get carbon neutral. The plan is simple. They are first going to start with renewable energy. Then they are going to change the equipments or the components to increase the effectiveness and the efficiency of the overall data center. They will be managing resiliency with either stationary battery storage, which is not commercialized yet. However, that is the plan that deal or that policy is dictating right now. So far, it seems that the road is not that much bumpy, but it's all on papers. We'll hear more from JD right now. So let's hear from him. Next slide, Nikita.
Wow, so that was a lot there. Well, the first thing I was going to say was how for this topic of conversation, how are we defining carbon neutral? There's every discussion I've been in, most of the conversations I've been in, has been how do you define? Everybody's got a different definition of carbon neutral and how it's offset and all those types of things. But about TMG Core, here at TMG Core, thanks for the introduction earlier. We focus on immersion technologies, single phase immersion and two-phase immersion cooling technologies, and we think we're helping in the process of getting towards something that, again, depending on how you define it, is carbon reduction. So we focus in developing technologies for high performance computing. We don't focus on things that are like standard rack, 10, 20 kind of thing, kW rack. We focus in the 80 to 200 kind of thing, kW rack, real high performance computing density applications, for both ASIC, GPU, and CPU applications for AI, ML, 5G, future 6G, if and when that comes into play. And we do that through, immersion, two-phase and single-phase immersion. I think most of the team folks that are joining the call likely know what that means. If you don't, you can always go to our website and check it out. And so, how do we make an impact? Well, you mentioned a lot in those couple of slides. Personally, I don't think there exists, it's a great term, carbon neutral. In the years and years that I've been looking into this issue, looking at, LEED certifications on facilities and carbon neutrality and the idea of using renewable energies, which is another whole topic of renewable energies and whether or not they're actually truly renewable, whether it's solar or geothermal or nuclear or wind or based. I mean, there's a lot of arguments out there about whether or not they're actually renewable. But that aside, I think getting to a point where we're significantly reducing or providing carbon offsets as it relates to data centers, that's where we come in. By no means is immersion cooling, whether it's single phase or two phase, going to solve the problem of carbon emissions, but certainly help with respect to water utilization and footprint. I think the biggest part of what immersion cooling, whether it's TMG Core or there's other companies that do immersion cooling, both single phase and two phase out there, good companies. I think one of the biggest opportunities for reduction in carbon emissions and therefore getting more towards a carbon neutral mindset is in the one where you can go in order to perform your computing applications, your data center operations, and also the size of those operations because of the significant density and reduced size. A lot of people don't realize that, in these data centers, you mentioned in China, 10 million square feet, I think you said it was. There's Microsoft has data centers here, and not far from here, Google does, and they're a million square feet or more. And they're running, 50 megawatts, 100 megawatts kind of applications. And just the cement alone, for every ton of cement that you put out there generates about 1.25, so about 25% more carbon, CO2. So for every ton of cement, 1.25 tons of CO2 is emitted through that process. Steel, for example, the process of steel, iron ore, and something called coking coal is put into these massive blast furnaces, and they generate huge amounts of CO2 and just developing steel. And so that includes your structural beams, your, all of those things, the window sills, the aluminums, all of those things that go into your data center, the raised floor, actual racks themselves, the servers themselves that are made out of metal and steel and aluminum and copper and all the things that are mined, all of these things, that process. So the idea of getting to a carbon neutral, again, depending on how you define it, but true neutrality, whereas you're not putting out more than what can be absorbed out there in the world, is, to me, is not something that's achievable. But if you define it in that you're using, renewable energy resources, again, depending on how you define renewable, because even if you look at solar panels, they require copper wiring, and it requires, which is mined, right? And, you've got battery systems, which cobalt and lithium and all those things are mined, and the batteries themselves are aluminum, and that's mined, and you need trucks to ship the panels, and it's silica, and the silica needs to be created into these photovoltaic cells, and the aluminum structures that it builds, that's all mined, and that's all shipped and trucked. And even if it was shipped and trucked in EV vehicles, you've got batteries, and most cars, even EV cars, are made up of petroleum products and plastics and rubber tires. And so the idea of carbon neutrality, to me, is a fallacy. That said, the significant reduction in carbon emissions, however you want to coin the phrase, carbon offsets. I'm not a big fan of carbon credits because I think it does something else. It does something on the other side of things where people can generate all this stuff and then they can sell the carbon credits, creates a whole nother market, which could be good for the economy. But that aside, but carbon offsets and reducing the amount of carbon dioxide emissions is definitely doable. And I think seeing companies like Microsoft and Google and Amazon and Facebook and all these other and a bunch of other folks that don't go out there and talk about it, who are doing something about it, are truly wanting to offset their carbon or significantly reduce their carbon footprint. And one of the ways that TMG Core helps in that process is by allowing them to build smaller, to go and build more in a decentralized way, using existing footprints. So, for example, the idea if you can repurpose, there's, if you look at all the buildings of all, and whether they're data centers or they're 7-Elevens or their Walmarts or their office buildings, that carbon's been generated. So that footprint exists. All that energy went in there, whether it was renewable power that was focused on, or it was coal or natural gas, whatever. That's already built. That stuff exists. So being able to repurpose those existing locations, facilities, and for this purpose, rather than finding a new location, digging a bunch of dirt, which, again, earth movers that use petroleum products and all this stuff, even if you've got battery powered, like I said, there's a whole bunch of carbon that gets pushed out from EVs as well. So the idea that you can now repurpose and go into and create a decentralized distributed nodal network, which has the same equivalency from a total computing power, petaflops, hexaflops, whatever you want to call it, kW, if you want to talk about energy from an energy perspective and power, in megawatts, kilowatts, what have you. The idea to repurpose and be able to go in those locations, be smaller, denser, faster, as efficient, as reliable, or in some cases more reliable when it comes to immersion in some cases, because you have fewer moving parts, no fans, things like that, which goes towards to your point earlier with respect to the PUE, where I saw on your slide there that getting to carbon neutrality was a 1.2 PUE. In the immersion world, that's terrible. Having a 20% of your energy going towards something other than the workload is extremely inefficient. Never mind, 40%. But one of the benefits of immersion cooling, and this isn't meant to be an immersion cooling commercial or anything, it's just factual, is that you get significantly better efficiencies because of just how the nature of the technology. And so you can be running at 1.0 something, right, rather than 1 point something. And so by definition, therefore, you're reducing the amount of energy you're using. Therefore, whether it's solar powered or wind powered or geothermal or nuclear or coal or gas or whatever, natural gas, you're using less of it. And therefore, there's a percentage of that power, whether it's, again, renewable or not, that is generating carbon emissions. And so if you're using less of it, then you're generating less carbon emissions by default. And then if you can repurpose, instead of building these new large giant facilities, and build small and just go into existing and retrofit and be able to get out there to the edge-based computing world, or in austere locations or even mobile applications, whereby you're able to do the computing that you need and fulfill your customers' demands, or if you're going to build much smaller, more efficient systems, using better materials, using much less water. I mean, just even the pumps that you use are steel and plastic and aluminum and the copper wires and all that stuff. So things like that, using less electricity, having smaller footprints on facilities, and being able to go and repurpose existing footprints will significantly reduce the carbon emissions and therefore help you get towards that carbon neutrality, however you define it, and also provide the offsetting, which I really think is where we need to have the dialogue, is really around carbon offsets, offsetting the carbon emissions versus going to creating a term called carbon neutrality, where you have to define it clearly first in order to actually even consider achieving something that's carbon neutral.
I think that's pretty straightforward. Even in fact, I also reconcile with JD on that if we are not able to define this term properly, I'm not sure what exactly we are going to achieve it. So let's move on to the next slide, please. JD has already introduced us to the impact of liquid immersion cooling. Here's some small research that we have done that actually tells us that okay, there is a huge impact coming in. Liquid cooling has the potential to reduce energy consumption by 40 to 50%, and this is based on research. In some research, it is also possible to reduce it to 70 to 80%. It depends on the technology that you are deploying, where exactly you are deploying, right? And it exponentially reduces the water consumption because, hey, there is no water being used. We are using dielectric fluid here. And the important aspect here is that the overall efficiency that you are achieving, as JD has uprightly said, that since you can build something that consumes less and it can be, talked upon, that we can reduce the overall carbon emissions. And liquid immersion cooling is one of the best ways, I would say. JD would, second me on that thought that it's one of the best ways to actually start somewhere, right? We can start with liquid immersion cooling now. It's already available. I mean, there are more than 50 companies that have started, of course, giving some sort of immersion cooling technology. Back in 2020, 2018, there were very less. I mean, there were, I guess, 15 recognized brands that time. Now, if you look at the market, there are a couple of Chinese companies also. I mean, recently I had a word with a salesperson from China. He was telling me that the market is actually outside China. Chinese people are not that aware, but they are coming in really great. JD has already, last time we interacted, he highlighted about that. Okay, there are few areas. He talked about India also, that things can happen and they are going to happen. Next slide, please. So if you look at this, just a small case study that we prepared, if you look at the entire data center, like how exactly this could, help us achieve and what exactly this could help us achieve. So data center capacity is 2 megawatts. Let's assume that, and there is an on-site renewable solar capacity of 2 megawatts. So that's kind of sufficient, but remind you, solar is not 100% resilient, because at night you're gonna need the power. Either you have supply agreements or you have a backup for it. So eventually you are going to switch to the grid and get that fossil fuel energy at night. Through traditional cooling, however, the 40% of the total power is being consumed to cooling itself. I mean, it's very conventional and traditional energy. This has been improved and moved down to 18% also. But when it comes to liquid cooling, overall consumption is reduced by 70 to 80%, and the total utilization for cooling is reduced to 4% and 12%. That means that we can rely on that solar power. We can reduce the energy agreements of 2 megawatts to 1.5 megawatts. And there is a serious or incredible savings in the OPEX. This is the start that I was talking about. This is what JD is also explaining, that we need to start somewhere. Liquid cooling is an excellent platform and is an excellent step towards, let's say, more greener, not exactly carbon neutral in terms, but yes, less carbon, more efficient. And if I'm not wrong, JD, you explained me earlier also that if the fluids are properly handled, they can last up to more than 10 years also. Would you like to give us a comment on that also?
Yeah, yes, and I'd like to back up a bit here just for a minute. Both, whether it's single phase immersion or two-phase immersion, there is a water requirement, and that requirement is for the final heat rejection. And so I just want people clearly understand that. And so it doesn't eliminate 100%, unless you're doing a dry cooler and you're in the smaller units. And then yes, that is an absolutely accurate comment. Where if you're running something like, we have systems, and I know other folks have some systems out there, but we have systems out there that are about 30 kilowatt racks effectively that have a dry cooler built in, and so there's no water consumption, there's no water discharge, there's no waste or things like that. It's extremely efficient. However, when you get into the multi-megawatt size systems, depending on where you're going, where you're going to deploy your technology, you may need an ADVAC system or some type of hybrid system, or even a chilling system. We've had people, we do the engineering all here in house. Even for the final heat rejection, we work with partners on that stuff, and we have to. It depends on, not all locations are created equal. The world is a very diverse place, and from a climate perspective, and so it depends. Like you're our friends up in Norway. Well, they're going to use dry coolers, right? Or they're going to tie into a glacier river or something like that, right? Where that's great, right? But if you're in Houston in the summertime, or you're in Abu Dhabi, or you're in India and Mumbai, you're going to have a challenge. And so there is going to be a water requirement. Now, that said, significantly reduced amount. So I just want to be clear about that. With respect to the power utilization and the OPEX application, yes, the OPEX is significantly reduced in liquid cooling because you have fewer things to go wrong. And the fluids that we use, to be clear, it depends on the type of fluid. there's lots of different fluids, and we could spend a whole day, and I'm open to having conversations with anybody who's interested in educating them on fluids. We have 2 whole fluids labs here where we do all the chemistries, working with all of the folks out there that we're aware of that make these fluids, whether it's Chemours or Solvay or Shell, or I mean the list goes on and on. Now, single phase, they typically last about 7 years, 5 to 7 years, depending on how hard you work them, i.e. how dense the type of computing is, excuse me, on the single phase stuff. And if you know how to keep it clean and use fluid hygiene and not get materials in there, then they'll last quite a while. And the beautiful thing about that is some of them, not all of them, some of them are fully biodegradable very quickly. So they add very little impact to the environment long term. And the process of manufacturing them is a byproduct in some cases of what's already being generated. So it's being generated in ways that would normally go away. This is being reutilized or, I guess, repurposed, and that's great. 2-phase fluids, however, theoretically last forever. Now, that can be a bad thing in some cases, people's mind, because it's around forever. What do you mean? Well, it has global warming potential. Well, with potential being the key there, because nobody really knows, because there isn't a lot of work done on that, and we're helping drive some of that in knowledge. However, the idea that it takes a while for it to break down. Well, okay, that's fine. So on the other side of things, it's positive because once it's made, and as long as you know how to use it, like we do, around filtration, keeping it clean, the hygiene, theoretically lasts forever. And so you never have to, and you can repurpose it and you can filter it. We have a filtering process. So if something were to happen, it got contaminated from dirt or whatever, even servers come right off the production line with solder flux and hair from the production. I mean, it's amazing what we've seen and filtered out from brand new servers right out of the box. And so having processes for cleaning this out, we use filtration processes, which are very low cost, very low carbon, not carbon neutral, but very low carbon processes for building these filtered carbon. They're actually carbon filters. And then they last for a very, very long time. So keeping the fluid hygiene is key. So yes, 2 different types of fluids. Within those 2 different categorizations of fluids, there's lots of different fluids within each category. Each of them has a benefit depending on the type of computing that you use.
Absolutely. Next slide, please. So we have been talking about liquid cooling and immersion cooling and its impact. We heard from JD also that how exactly that is impactful. It's something that we can really look up into the future. However, I would also like to highlight some of the other technologies or, some of the other things that can actually help us achieve a lot of things or a lot of, reduction in carbon with respect to data centers. These 4 things that I would like to highlight are floating data centers. I mean, Microsoft has, they have started utilizing or not started, they are piloting this, yet to receive what exactly is the total output of it, how much energy it is being consumed, and what exactly are the dynamics of such floating data centers. There are other companies such as Kepler. They have recently, received a regulation go ahead from Singapore. They are going to build a floating data center there. Then, of course, waste heat utilization. Our Nordic friends are Nordic data centers. They are using it a lot. AWS data centers in Norway and Apple data center in Norway. Apart from that, majorly data centers that are in colder climates, the heat from the process is being reutilized for district heating, especially for public buildings, swimming pools, and government offices. In some cases, there are case studies where smaller communities are also getting benefit out of it. They're calling it digital boilers, basically. Then we have small modular reactors for data centers. I'm really excited about it. Having a nuclear power backed up to a data center, that means 24/7 energy for, I don't know, maybe 100 years. But of course, there is a catch there. You have got to refuel it, and the fuel costs are very high. In-campus renewable energy production, we have already talked about this. Let's see what are some companies that are doing in these areas in the next slide. So I've already talked about Project Natic, which is basically a Microsoft endeavor. It's an underwater data center, just the coast of Scotland. So far, it's doing good. We have not, I mean, Microsoft has not released any details related to the operability and its dynamics. There is Nautilus Data Center. Uh, they launched a water-cooled data center barge in Stockton, California. Uh, it's running high, it's running good, although the overall capacity is not comparable to the large co-location or hyperscale data centers. It is something that all these companies are trying to look into. Kepler data centers have invested $10 million in 2021 to Nautilus data centers. That means they are also trying to get into this particular market. We have a small French startup, DNVR. Fun fact, the CEO of DNVR was supposed to join us today, but they are very much tied up with to launch their first prototype in Nantes. So they apologize that okay, we are not able to do this time, but of course we can have them again in some of the other webinars here. So call out to DNVR. They are doing pretty great. I mean, I have seen the designs, pictures that were shared by CEO, and it's a nice concept for smaller things, but uh, of course, it's something that they are starting. The dynamics are not yet clear, but we believe that uh, it might put some impacts in specific locations. Of course, it's not, as JD has said, that not all solutions are for all locations. I mean, you have a different solution for Nordics, you have a different solution for Houston, and of course, the climatic condition in India does not allow us to go 100% carbon neutral. It's already 45 degrees outside and it's very humid. You require that chiller. Then we have waste heat utilization. As I said, majority of this is happening in the colder climate. Switzerland, the Nordic regions, Iceland, they are doing this. Then the interesting one, small modular reactors for data centers. There are not much companies that are available right now. The two primary companies that are doing great with respect to data centers are NewScale Power and Holtec SMR. Uh, Holtec SMR is trying to develop a molten salt reactor for data center and industrial applications. We are yet to see the commercialized product yet. It is also compared to some of the most important developments with respect to the energy, especially industrial power generation, because we all know solar and wind is limited. You can only get solar energy in the day, and you can only get wind energy when it's windy. I mean, it's limited. So my fourth table is just a representation of how different data centers across the world are utilizing, renewable energy. Google, as I said, 100% of their operations, including IT infrastructure and data center, is run on renewable energy itself. It's a mix of some agreements from the local vendors and in-house production as well. It's a mix of solar and wind right now, but we can see that this is common across the four big hyperscalers: Google, Facebook, Amazon, and Microsoft. I would like to highlight Alibaba also because it's the largest hyperscaler in Asia Pacific. There are 6 data centers in China, large data centers, I'm telling you, which are running on liquid cooling technologies. Although it's not clear whether it's an immersion cooling tech or a direct to liquid tech or what exactly they are doing this or how exactly they are using it. But it's clear uh, it's from someone from Alibaba itself. That means that this technology, liquid cooling technology, is not limited anymore to US and Europe also. Countries like China, countries like Singapore, countries like Japan and Korea, who have a high motivation to become data center clusters in future, will really look upon this particular technology. So coming on to the next slide, we'll just move on to the conclusion. So we'll just try to see what's the adoption scenario and the future outlook for this particular market. So I am terming carbon neutral data centers as an entire market. JD would, not second on that. The definition is vague, but for people who have a limited knowledge to the definition and has limited access to the definition, we'll just stick to the name right now. We can define it later on. We can term it differently. currently the market or the currently overall 2% of the world data centers are partially or completely carbon neutral, which I've already shared with you guys. Majority of these data centers are present in Iceland and the Nordic region. There are more than 200 companies that are operating in the ecosystem, contributing or trying to contribute to reduce the overall carbon emissions from the entire industry. These companies includes companies like TMG Core, who are offering cooling solutions, Submer, companies like Shell, who are offering the fluids. There are component manufacturers also such as Stobly that are trying to develop new products that are, that can go with the upcoming technologies and the liquid cooling pipes and all that stuff. And we have IT infrastructure vendors and huge multinational companies such as Siemens, Intel, all in line to achieve what is already been dictating, reducing the carbon emissions. We believe that there is a possibility and we expect the market to grow at 40% CAGR. We are talking about immersion cooling market in next 5 years. 40%, it's huge. Why? Because there are data centers that are adopting this technology at a larger pace. Although, unfortunately, as JD said, that large data centers will find it difficult at this moment because when the size is that big and the demand is high, although the supply is not that high, which is one of the few challenges for this particular market. Unfortunately, we will see the adoption more in the edge or the modular data centers, which are smaller, traceable, and scalable, and are, somewhere down the line going to replace the large data centers altogether. I mean, that's way beyond the future. As I was telling Iceland, I'm very much excited to visit Iceland someday, but right now I just know that it's the only country in the entire world where all the data centers are technically carbon neutral. We are not talking about the scope 2 emissions where, the silicons and the components and all that stuff, lead to some carbon emissions. We are only talking about the operations here. All these carbon. So Nikita, let's change the slide, please. So currently, the country has a capacity of somewhere around 1,000 to 1,200 gigawatts hour. There are 10 co-location data centers, 11th one under construction, and these are huge data centers. There are other modular small data centers also operating in the market, but their share is pretty much less. All these data centers are running on 100% renewable energy, a mix of 70% hydroelectric and 30% geothermal. The energy or the heat that is being, generating from these data centers are being utilized for office cooling and district cooling. And of course, it's the most important region, or you can say it's one of the most data center important countries for data center. Why? Because that particular piece of land is situated near the North Atlantic subsea lines and the Scandinavian Black Sea lines. So it makes it a crucial center, not for the world, but eventually for that particular region. We are talking about FLAP market, and somewhat it is going to assist the large markets to offset their, that overall consumption, or somewhere down the line, it's going to help out, of course. Key companies are Advania and Vern Global. We had a couple of conversations with Vern last year, and they are pretty much excited to launch another data center in Iceland. So right now, there are no big hyperscalers that are investing in this particular country. Eventually, maybe because it's smaller in size and, technically you have to ship everything from UK to that island, which makes it very expensive to develop data centers. We are talking about all the infrastructure requirement, every device, everything is being imported because it's not being constructed there easily. Let's move on to the next slide, please. So this is for all the overall technologies, this is a basic chart that we believe is somewhat true based on the current experience that we have. Currently, there is an increased adoption of immersion cooling technologies and in-campus renewable energy production. By 2025 and 30, we will see more new floating data center facilities. Reusing heat will be almost from all Scandinavian data centers, almost 100%. By 2030 and 35, almost one third of the data center capacity is going to be cooled by immersion cooling. And that's based on the current scenarios. It might be more than one third also. And I think that scenario is something they would be looking forward to. And in 2035 and 40, we believe the small modular reactors will get commercialized for data center usage. I mean, it requires time. I mean, you are developing technology, you can't do it in 1 year. It requires time. As I said earlier, also in 2030, there is a huge event coming in, launch of 6G, that's going to change the entire data center aspect, the way we think about it. Large data centers, I'm assuming by 2040 will be running on immersion cooling, partially at least. The average PUE levels will reach up to 1.01, hopefully. And modular data centers and the edge data center will outnumber the large data center operations. I mean, it's quite evident. We are seeing more traction in that particular type of data center because it's easy, scalable, and I can have a data center just parked outside my home for the entire community. It's helping everybody out, and you can deploy immersion cooling very successfully to that particular piece of machine rather than focusing on hyperscale. Any thoughts on that, JD?
No, I like it. I like it. I think it's going to accelerate. I think this is a good timeline, and I think it's going to accelerate. I think, especially on the modular data center side, we're involved in something right now, as I'm sure other colleagues in the industry are, where we're rolling out a very significant edge-based, decentralized, distributed mesh network of micro data centers, right? And so those are effectively, in many cases, because of the location, they're considered modular, right? Because they can be, because they're smaller in nature. They don't need all the infrastructure and connect. As long as you have connectivity, you're near a fiber, point, connectivity point. Then you've got built-in dry coolers. You don't have all of that stuff that bolts down, right? So that, I think that's going to accelerate. I think you're going to see that sooner. I think you're going to see that around the same time. I think in parallel with the immersion cooling. I think that's accurate. I mean, that's only 7 years away. I mean, when you look at 2030, you go, woo, 2030, but it's like seven. And at my age, 7 years goes by like, I woke up this morning and I was like, wow, it's a couple of years have gone by. So, it goes by fast. So yeah, I like the timeline. I just think what we're going to see is the modular data center side outpace that timeline.
Understood. And I can reckon that. Next slide, please. So there are a couple of key challenges to address, of course, right now. The cost of implementation, I believe that's one of the key concerns that data centers are having. We cannot apply immersion cooling into a retrofit situation. You cannot convert an older data center suddenly running on immersion cooling. You need new data centers there. Of course, the other type of technologies, let's say D2C and some in-rack and in-row liquid cooling solutions can be retrofitted. However, if we are looking into a power density capacity of more than 20 kilowatts, you are going to require immersion cooling. I mean, because beyond that level, nothing is going to be efficient more than immersion cooling. Then there is availability of technology. Data center industry is a multi-billion industry. It involves a lot of data centers. I mean, you cannot count how many data centers there can be globally. I mean, some people have tried. I also tried, but it's beyond my imagination. That means to convert all that to immersion cooling is a bit difficult at this or right now. Manufacturers need to scale up their production, or at least the developers needs to scale up to match up that expectation. We need to really look into new upgrowing data center markets such as India, Singapore, Hong Kong, Malaysia, Indonesia, Philippines, China, and of course, apart from FLAPs, there are a couple of other data center hubs that are coming in. We can look into that also. So there is a serious crunch in availability of technology. Carbon neutrality is not an immediate concern for data centers in some region. I've talked to so many people, especially in India and Asia Pacific. There are some countries people are not even aware that they have to be carbon neutral in some time. They are just worried about the resiliency or running their data centers 24 by 7. Uh, there is only one data center in Laos, and Laos in the entire region has some of the worst outages, power outages. Uh, in some regions and some cities, on some places, it's even possible not to have an electricity for an entire day, maybe two. And we are hoping that they have more number of data centers because it is required. But without the continuous power supply, that data center is going to do nothing. So their concern is pretty much on a different level as compared to the concerns that FLAPs and US markets have. So that is there. Last one is, of course, limited awareness. Uh, People are not actually aware that with immersion cooling, they are reducing the capex, and the ROI that they are getting is much more higher as compared to conventional ones. They are just fearful that the cost of implementation is so high, and they are not getting any ROI maybe in next 10 years. I mean, that is a fear that I have seen in some of the data center operators operating in India also. They have so much to scale up. So these are the four key challenges that are, I think, on a grassroots level we can start addressing. With this, I would like to conclude the entire PPT. After that, we will be starting with our Q&A session. These are some reports that we have published with respect to data centers, and there are some upcoming titles that we are hoping to do with, of course, with your support and all. So anybody who is looking forward to have these titles, or want some more information related to these titles, they can contact us. You can go to our website. There is a contact us section. You can put up your message, and you can directly, somebody will contact you. Or after this webinar, you can, directly contact me or Nikita. You can share your email IDs. We can catch up. Even if you want to share some knowledge related to data center, we are all up. We want to hear more. So interestingly, I would just like to introduce all of you to this particular tool. JD, it's a very interesting tool. Okay, we have recently came up with this particular tool. It's called Insight Monk. Basically, what it does is there is an AI platform where you can get access to more than 1 million strategic reports, which are downloadable free of cost. Okay. Uh, Normally, if you do this operation on Google, it'll take you 1 week to identify one single document. But with this tool, we are able to do this in a one single day. It's very efficient for us. Uh, there are more new things that we have recently launched in it. There is a chat GPT like uh, tool that is Insight Navigator. You ask questions, it'll give you the specific answers related to the markets and all. So I would really like all of you to visit Insight Monk, check the what exactly it's going to offer, and we can help you on board to that particular technology or on that particular tool. So with this, I would like to open the house, or lay foundations for any questions for us. uh, if you want, we can take on the questions elaboratively also later, where you can share the questions and we can share it over your emails with elaborative answers. If you want short and crisp answers, you can shoot the questions. So we will be waiting for 2 minutes for your questions. Later on, if you have any other questions, we can simply take on that questions, and we'll give you some elaborative answers later on. So JD, I have seen majority of the times people actually share the questions and we prepare an elaborative answer. So I'm seeing one question coming in.
Okay.
somebody was writing. I don't know if they are anymore.
I get off easy this time.
Maybe JD, having you on the conversation, it makes things very clear. We were clear, simple, and less complex terms.
Well, I'm always here. If you have any questions in the future, feel free to reach out. And
Question to speak. Okay, so we have a question from Jeremy Walters. Do you see a role for fuel cells running on hydrogen as part of the solution? I think this could be addressed. JD, would you like to take on this?
Sure. Short answer is I think there's a great future for hydrogen fuel cells, given the right technology, given having the right cost price point. I think it's going to get to the point where, like you pointed out earlier, even in the immersion system, business, or I remember direct to chip, now that's being widely adopted. It's got to get to the point where it's cost effective, right? But hydrogen fuel cells in general, I speak to a lot of folks about that, a combination of hydrogen fuel cells, immersion cooling systems, vehicles for hydrogen cells, power generation. I mean, the idea that, it's a very, very relatively carbon neutral technology, and it's clean energy as well, right? I do.
Right.
Personally.
So short answer, I would also second with JD. There is a catch, although to produce hydrogen, you require a lot of energy, especially when it's how exactly it is being generated, where exactly it is being generated. Apart from that, just to make sure that we have proper resiliency in data centers. Data centers keep UPS systems and diesel gensets, and hydrogen fuel cell batteries or hydrogen fuel cell can actually replace these gensets, further reducing scope 3 emissions from data centers. It is possible.
Yeah, I think what they call quote unquote renewable energy, like solar and wind and geothermal, things like that, having hydrogen, using that energy to generate the hydrogen, to then to have the storage during when the wind's not blowing, the sun's not shining, and whatever, I think is a lot of value. And if you can put it in portable containers and containerized vessels and things like that, then yeah, I've had folks in my office here pitching me on ideas and what's coming next. It's pretty amazing what's coming next with hydrogen.
So yeah, I think people want to speak up, but unfortunately the mic is restricted to for the audience. We have posted an email. You can elaboratively ask questions through that particular email. We'll be happy to assist you. I mean, of course, we'll require at least 1 or 2 days to answer that properly. With this, I guess we can conclude this session, JD. As you said, the sun must shine. I hope it shines on you, me, and everybody who has joined this event. Especially looking forward to those, announcements that you promised me in 2023. You told me in January there are some announcement coming. Guys, please, have your seatbelts tighten up. TMG Core is coming with huge surprises this year.
Thank you very much. It was great having me on, and it's always great having conversations, and you always have a good audience. So thanks for having me.
All right, guys. So with that, I would like to, close this session. If you have any questions for me, you can post. If you have any question for JD, please use that email to share this with us. In future, if you want to connect with us, you have our email IDs. We'll share much more information. We would like to hear more from you. We would like to interact with people on a daily basis. Thank you everyone to join, and have a great night from India, and have a very good morning at your end, JD. Have a great afternoon ahead.
Cheers, guys. Bye.
Thank you, guys. Bye-bye.